Yes, good morning, students. Welcome back to the recorded video session. This session is on the lab program, Part B lab program. So today I'm just going to explain you how to write an embedded C program to interface and control a DC motor. So this program is the lab program number 10. In the previous session, I explained you how to make the LEDs blink. I showed you two examples how to make one LED blink and to make 8 LEDs simultaneously blink using the protest simulator, and the C program was written in the Keel IDE, compiled, and the X file was generated, and the same X code was written to the microcontroller in the protest simulator. And then in the simulator you observed how the LEDs they blink. Now today that was not the lab program, that was just a sample program. Today what you're going to learn is the lab program, which is on interfacing and controlling the DC motor. I hope the DC motor, all of you know this, because everyone, I assume, in your childhood days, most of you, if not all, played using the DC motor, the small DC motor. Now you're going to control this DC motor by writing your own embedded C program. Yeah. Now, what is a DC motor? I have the pictures also shown here. I think in your childhood days, majority of you might have used these motors, DC motors. This is it has two terminals. You can see here. This is one, and this is the internal diagram, how it operates. I'll come to this later. I think now you got an idea what is a DC motor and how it looks. This is not an unfamiliar thing. This is familiar thing because most of you have used in your childhood days, and even now also you might be using it. A DC motor is a class of rotatory electrical motor, now which will convert the direct current into the mechanical energy. And it works by using the forces that are produced by the magnetic fields. Now you can observe here, this is how this is the schematic diagram. Internally it is something like this. You have the North Pole and the South Pole. These are the permanent magnets. This is North Pole magnet, and this is the South Pole magnet. This is the armature coil. What you can see the windings here. Now when you supply the positive and negative voltage to this, you have this acting as the North Pole and this acting as the South Pole. Because anything with the windings, when you supply the voltage, the potential difference, it acts as one acts as the north and the other one acts as the south. When this is acting as the north, this North Pole and this North Pole, they repel, and this again south and south, they repel. So this north gets attracted towards the South Pole. It's pulling like this, and this North Pole itself is pushing. This pole is pushing this end, and this pole is attracting this end. And similarly, this pole here, it is pushing this, repelling this end, and this pole here, it's trying to attract. This is how it rotates. And if I just change the polarity here, if I make this as negative and if I make this as positive, so it rotates in the anti-clockwise direction. This is how basically the DC motor works. Now for explaining, because I'm not going to control it just by giving the power supply to the DC motor using a cell or a battery. Now we're going to control this by writing our own program. Now this is the schematic diagram. This is the DC motor with two terminals. So this is one terminal and this is another terminal. Now what I'm doing, so this terminal of the DC motor, I'm connecting it to P0.11. I'm connecting it to the port pin P0.11, and the other terminal I'm connecting it to P0.8, port pin P0.8. So these are the two ports of the microcontroller LPC2148. Now and in the last class I also explained this LPC2148 has got two ports, port 0 and port 1. Now port 0, you can use all the pins from P0.02, sorry 0.02 0.31. Totally 32 port pins are available in port 0, and similarly in port 1 you have 32 port pins available, but usable are only from P0.15 to P0.31. P0.02 P1.02 P1.15 they cannot be used by the user. Now in port 1 only the user can use the port pins from P1.16 to P1.31. Now I'm in my program, I'm using the port pin P0.11 and P0.8 to connect my stepper motor terminals. Now why I have chosen P0. Is there any hard rule to choose P0.11 and P0.8? There is no hard rule as such. I have used. Now in the these programs will be executing. Now I'll show the simulation of these things, but when you come back to the college, all these programs you got to execute it on a kit, hardware kit. The kits are supplied by the ALS. And there all these connections are made already. Now the stepper motor is permanently connected to P0.11, and the another terminal of the stepper motor, the DC motor is permanently connected to P0.8. Now hence I've taken the same thing. Now for simulation purpose also I'll try, I'll show you, I'll change these port pins and I'll also show you the output. Say for example P0.0 and P0.1 I can use it, but so this will also help you for the laboratory purpose. The same program, everything is same, logic is same, and now you'll understand how to change the port pins in the simulation. But when you are doing it for when you want to execute this program in the hardware on the ALS supplied kit, so the DC motor is permanently connected to this port pin, and another terminal of the DC motor is permanently connected to this port pin, and when you're writing you have to use these ports itself. Okay, now we'll start this. This terminal is connected to P0.11 of port pin of LPC2148, and this terminal is connected to port pin of P0.8. If I apply say logic 1 to this particular port pin and 0 to this particular port pin, so the DC motor here starts running in the clockwise direction. That is what is given here. One is positive and another terminal. One is nothing but the positive voltage, and 0 is nothing but the common or the negative. Okay, it's common. Now there is a potential difference. When I apply 1 to this particular terminal, now the motor runs in the clockwise direction. Now the motor starts running. This you cannot control. DC motor, once it starts running, so it runs fast, say for example 600 RPM per minute, or 1000 RPM per minute, or 2000 RPM per minute. It depends on the specification of the DC motor. So many rotations it will be doing per minute. Now and if I want to, now it's running in the clockwise direction. When I do this, when I give 1 to the port pin 0.11 and 0 to port pin 0.8, it is running in the clockwise direction. Say it is running in the clockwise direction at 600 RPM, so 600 rotations per minute. Now I want to make it rotate in the anti-clockwise direction. All of a sudden I cannot do it because it is running in the clockwise direction at 600 RPM. What is that I have to do? I have to stop the motor first, and then I have to change my input to the port pins. Now how to make the motor stop? So just make this 0 and this also 0. Port pin 0.11 as 0, port pin 0.8 also as 0. The motor goes off because there is no potential difference. The motor goes off. And next, after some delay, what I'll do is, now I'll make P0.11 as 0 and P0.8 as 1. Now you have the motor, earlier it was rotating in the clockwise direction, and when you give this value to the port pins, the motor stops. And next, when you apply this value to the port pin 0 to P0.11 and 1 to P0.8, it starts running in the anti-clockwise direction. So the same logic which we are going to use in order to write the embedded C program now. Now this is the program, DC motor embedded C program. Now you got to include the header file LPC214X8, because this header file is the header file which applies for all the LPC214 series, LPC2148, LPC2142, LPC2145, etc. And the same header files also holds good for, so instead of this 4 I can also put X, because it also holds good for LPC21 series, LPC2138, LPC2132, LPC2135, all this. So this is I can say a generic header file for majority of the low power controllers. Next, now in my program, so I am using two user defined function. So these are the function prototypes. Now since I'm writing the definition of these functions clockwise and anti-clockwise after the main, this is the main function here. What you're seeing says the definition of anti-clockwise, clockwise and anti-clockwise are given outside the main, hence I have to give the prototype for these two functions. Now the prototype goes like this: void clockwise, that means it gives an indication to the compiler that so there is an user defined function with the name clockwise and its return value is void. That means the clockwise function is not going to return anything and it is not taking any argument. That is void again. Void means the clockwise function, you are not passing any argument. And similarly, so this statement, the prototype for the second user defined function, this statement gives an indication to the compiler that there is an user defined function with the name anti-clockwise, and again the return value of that function is void. It is not returning, it's not going to return anything, and it doesn't take any parameter. And I have one global variable unsigned int j is equal to 0, and this I'm using for the looping purpose, because here I got to specify the delay. Just to give the delay, I'll be using this variable j, and initially it is initialized to 0 and this is made as a global variable. That means this variable j I can use inside my main function, and I can use it in my user defined function clockwise and user defined function anti-clockwise. Now inside the main, now pin cell 0, since here I showed you I'm using the port pin 0.11 and 0.8. Now pin cell 0, since these two, so these two comes in the range P0.0 to P0.16, and in the previous class I already explained. Now to make the port pins P0.0 to P0.15 operate in the general purpose input output mode, I have to make use of the pin cell 0 register and put all zeros. Say for example P0.0, port pin P0.0, to make it operate in the general purpose IO mode, so the 0th bit of pin cell 0 and the first bit of pin cell 0 must be made as 0 0, and now here 8 zeros are there. Now each 0 can be written as 4 zeros in binary. 8 into 4, 32 zeros. And how many pins? P0.0 to P0.15, you have totally 16 pins there, and 16 bits here can make. So this is an hexadecimal value, these are not the bits. This 0 is again written as let me write it. Now I have to put 32 zeros: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32. So I have written 31 zeros here. So the least significant 4 zeros, this 0, this 0, this 0, this 0, corresponds to what? This 0. And next 4 zeros, this 0, this 0, this 0, this 0, corresponds to this 0. Like this, I have 8 digits here, and each digit in binary is represented by using 4 zeros. And 8 into 4, 32 zeros. And to make the port pin 0.0 operate in the general purpose input output mode, these two bits must be 0 0. And to make the port pin 0.1 to operate in the general purpose, next two bits must be 0 0. And to make the port pin 0.3 operate in the 0.2 operate in the general purpose input output mode, the next two bits must be 0. So like this, you have 32 bits and the port pin 0.0 to 0.15, totally 16 pins, and here 32 bits. 2 bits are required to make each port pin operate in general purpose input output mode. Now what this statement is doing is, it's making all the port pins 0.0 to 0.15 operate in the general purpose input or output mode. Next, now this also explained in the previous class. So this is the direction register for port 0. Now I want to tell, so this makes all the port pins from 0.0 to 0.15 operate in the general purpose input output mode. Now if I want to make a P 0.16 to 0.31 to operate in the general purpose input output mode, now which register I have to assign? I have to assign it to pin cell 1. Pin cell 1 is equal to, again, 0x8 zeros I have to write. Now that statement will make P 0.16 to P 0.31 operate in the general purpose input output mode. Now general purpose input or output mode. Now what we have to do? Now we have to make these 2 port pins, because I am connecting my one terminal of my DC motor to P0.11, another terminal of my DC motor to 0.8. Now I got to make these 2 ports as output pins. I have to make these 2 port pins as output port pins. Why output port pins? Because you are sending the data from controller to the motor. When you are sending the data from controller to external device, and external device here is the DC motor. Now remember, when you are sending the data from the controller to the external device, it may be any external device, so the port pins you got to make them as output port pins. If you are taking the data from external device to the controller, microcontroller, then the port pins has to be made as input pins. Now how to make them as output pins? You got to make use of the direction register. Since the P0.11 and 0.8 come in the port 0, I have to make use of IO0 DIR. So if the port pins come in the port 1, then I have to make use of IO1 DIR. So now IO0 DIR is equal to, so this is the data I am assigning, 0000900. Now why this 9? Because when I write, it is binary. So from the left side you observe. So these 4 zeros corresponds to this 0, and the next 4 zeros corresponds to this 0, and these 4 1 0 0 1 corresponds to 9, and to the left side you'll be having all zeros till the 32nd bit. Now why I've taken 9 itself? This is P 0.0, P 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and this is 0.8, port pin 0.8, and this is port pin 0.9, this is port pin 0.10, and this is port pin 0.11. Now my intention is to make port pin 0.11 and port pin 0.8 as the output port. Now this 9 is nothing but what? 1 0 0 1, hence the data 9, so this data will make the port pin 0.11 and port pin 0.8 as the output pins. In the previous class I explained, now when you make the corresponding bits in the IO0 DIR, in the direction register as 1, the corresponding port pins will be made as what? Output pins. Now these 2 bits in this register are made as the 8th bit and the 11th bit in the direction register IO0 DIR are made as 1. Now this, when you make them as I in IO0 DIR, the corresponding port pins, that is P0.11 and P0.8, so they will be made as output pins. Now we have these 2 acting as output pin. Assigning this value to this register will make these 2 port pins act as output pins. Next, we have an infinite loop here, while 1, it runs forever. That means when you run your program, when I run this program, load this program to the controller and run, you have the DC motor running clockwise direction for some duration and stops, and then runs in the anti-clockwise for some duration, stops, and then again starts running in the clockwise direction, some duration, stops, this clockwise, anti-clockwise, clockwise, stop, anti-clockwise, clockwise, stop, anti-clockwise. The process repeats. Hence I have written inside a while loop. So this one. So I'm first calling clockwise. I rotate the motor in the clockwise direction first. Now to rotate the motor in the clockwise direction, what is that you have to do? Here. You have to make P0.11 as 1. Yeah, here. Now I'll just come. You're calling the function clockwise. Now that is what I told. You're not passing any argument. In the function prototype, it was written as void. Now it comes here. Now before starting, so before making the motor rotate in the clockwise direction, I just want to make sure that the motor is off. So I have to stop the motor initially. I have to start from the stop state of the motor. Now what I'm doing, I'm giving the same data. Data is same. Now when I assign this data to IO0 DIR, it made these two operate as output port. Now assigning the same data to IO0 CLR, even this last class I told, if you want to clear the port pins, now you got to assign the data to IO0 CLR. You got to assign, make the corresponding bit as 1 in IO0 CLR. The corresponding port pin will go low. Now what I want to make P0.11 equal to 0, P0 go low, and P0.8 also go low. Now what is that I have to do? I have to make this assign 1 1. This is corresponds to the port pin. This bit in IO0 CLR now 9 I have given 1001. So this bit in IO0 CLR corresponds to port pin P0.11, and this bit corresponds to the port pin P0.8. Now when assign this to IO0 CLR, so these two will be pulled low and the motor is off. When this is what I told. So when they are 0 0, motor is off. Now why I'm making the motor initially itself go off? Because I want to always start from the state stop state, or the motor stop state. And next I make the motor remain. Once I assign these values, the motor goes off. Now I want to make the motor stay in that state for this duration. That means now once I apply these low values to port pin 0.11 and port pin 0.8, the motor stays. The motor stays in the off state. Now I want the motor to continue in the same state as long as the microcontroller repeats these many number of iterations. See, this is, so this statement is not under this for loop. You can observe this, there is a semicolon. Now when you put a semicolon to the for loop, so there is nothing under this statement. Only this loop starts repeating. So don't be in a confusion that this statement is executed for so many times. You don't have this statement executing for so many times. Now it is only just looping here itself. J is 0, J is incremented, and it keeps repeating here only in this for loop as long as it reaches 4 lakh. Once it reaches 4 lakh, so it comes out of the for loop. And then until that time, what was the state of the motor? It was in the stop state. After that, now I have to tell motor rotate in the clockwise direction. Now to make the motor rotate in the clockwise direction, what is that I have to do? I have to make this as 1. That is what I am doing here. Now instead of 9, I put the data 8 here. Now when I write 8, instead of 1001, it is 1000. This is the data 8. Observe here, this bit is corresponding to P0.11, and that is 1. That because I am assigning to IO0 set. So the corresponding port pin will be pulled high, and since this is the 8th bit of IO0 set, which is 0, the corresponding port pin will be pulled low. P0.8 is 0. Now the stepper motor will start running in the clockwise direction. Now how long it will run in the clockwise direction? Now after this assignment is done and the motor starts rotating in the clockwise direction, so this is the end of the clockwise. It returns from here, where it goes, it comes here. Now immediately after this clockwise function call, we have a delay. See, I am running this delay for 10 lakh iterations. 10 lakh iterations. Now for 10 lakh iterations, still the microcontroller completes, and again there is a semicolon here. Till the microcontroller completes this 10 lakh iteration, we have the motor running in the clockwise direction, because P0.11 value is 1 and P0.8 value is 0. The motor is running in the clockwise direction. And then after this delay is over, now I am making a call to anti-clockwise. Now it comes here to the anti-clockwise. Now again, now the stepper still, now it is running in the clockwise direction, at 600 rpm or 1200 rpm per minute. Now all of a sudden I cannot make it to run in the anti-clockwise direction. What is that I have to do? I have to stop the motor. Now to stop the motor, same thing what we did here. Now IO0 CLR is equal to 0x00 Now I am giving 1 and 1 to this bit, 11th bit, and the 8th bit are made 1 and 1 in IO0 CLR. The corresponding port pins will be pulled low. That is what is clear. The corresponding port port pins will be pulled to low. This is 0, this is 0. What will happen? This stop motor stops the stop motor by making P11 as 0 and P8 as 0. Next, now I want to make this stepper motor remain in the stop state for some duration. This is what the loop. Again, you can observe the semicolon here. Now it keeps looping here only. After this loop is done, it comes here. Now I have to do the opposite. Now to make P0.11 as 0 and P0.8 as 1. What data will do that? 1. Observe here. So these 4 0 color differentiation also I have given. This 4 zeros in the black corresponds to this 0, and these 4 zeros in the blue corresponds to this 0, and these 4 bits here corresponds to this particular 1. This 1 is written as 0 0 0 1 in binary. Now, so this is 0, that means the 11th bit in this register is 0. That will pull down the corresponding port pin 0.11 to 0, and since the 8th bit of IO0 set is 1, it'll I made a mistake here, sorry. So 0.8 will be 1. 0.8 will be 1. So 0.8 is 1. This is low and this is high. This condition now. Which condition? This is 0 and this is 1. The motor starts running in the anti-clockwise direction. It starts running in the anti-clockwise direction. The moment this is done, where the control goes, the control comes back here, and the controller will start doing this iteration for 10 lakh counts till the controller finishes doing this 10 lakh iterations. You can observe the stepper motor running in the anti-clockwise direction, and after that again while it goes again calls the clockwise delay, anti-clockwise delay, so the process repeats. I hope you understood this. Now let me go to the execution part. So the program is clear. Now for the execution part, I'll just copy the same program. Before that, let me